2002 edition of the National Electrical Code, often referred to as the NEC, specifies that brown, orange, and yellow are the designated colors for the three-phase ungrounded delta system. This specification is outlined in section 210.11 of the NEC. The code also indicates that the colors brown, orange, and yellow should be implemented for the three-phase ungrounded Y system, specifically in situations where a neutral conductor is absent. It's crucial to acknowledge that the NEC undergoes periodic revisions and updates. Consequently, color coding regulations for three-phase systems are subject to modification over time. For the most accurate and current information, it is always advisable to consult the most recent edition of the NEC. The NEC addresses various aspects of electrical installations, encompassing wiring methods, overcurrent protection, grounding, and equipment usage. Adherence to the NEC is vital to ensure electrical safety and code compliance in any project involving electrical systems. Within the context of the NEC, different wiring configurations such as delta and Y systems are addressed, each having specific grounding and color coding requirements to facilitate safe and efficient electrical distribution. Grounding, a critical aspect of electrical safety, involves creating a low impedance path for fault currents, thereby minimizing the risk of electrical shock. The NEC specifies grounding requirements for different electrical systems, including the use of grounding electrodes and grounding conductors. Color coding plays a pivotal role in identifying different conductors within an electrical system, helping to prevent wiring errors and ensuring safe operation. The NEC provides color coding standards for different types of conductors, including phase conductors, neutral conductors, and grounding conductors. These standards are intended to promote consistency and clarity in electrical installations, reducing the likelihood of accidents and facilitating troubleshooting. Overcurrent protection devices, such as circuit breakers and fuses, are essential components of an electrical system designed to protect against overloads and short circuits. The NEC specifies the requirements for overcurrent protection devices, including their sizing and location, to ensure adequate protection of electrical circuits and equipment. Wiring methods encompass the various techniques and materials used to install electrical wiring, including conduit, cable, and raceway systems. The NEC provides detailed requirements for wiring methods, specifying acceptable materials, installation practices, and protection measures to ensure the safety and reliability of electrical wiring systems. Equipment usage is another important consideration in electrical installations, as different types of equipment have specific requirements for wiring, grounding, and overcurrent protection. The NEC provides guidelines for the safe and proper installation of various types of electrical equipment, including lighting fixtures, appliances, and machinery. In addition to these specific topics, the NEC covers a wide range of other electrical safety requirements, including those related to hazardous locations, emergency systems, and renewable energy systems. Adherence to the NEC is not only a matter of legal compliance, but also a fundamental aspect of ensuring the safety and well-being of individuals who interact with electrical systems. The NEC is developed and maintained by the National Fire Protection Association, a non-profit organization dedicated to reducing fire and other hazards. The NEC is updated every 3 years to reflect changes in technology, industry practices, and safety standards. The NEC is widely adopted by state and local jurisdictions throughout the United States, and it serves as a model code for electrical safety in other countries as well. While the 2002 edition provides a valuable historical reference, relying solely on it may lead to non-compliance with current regulations. The NEC undergoes regular revisions to incorporate advancements in technology, address emerging safety concerns, and refine existing requirements. Therefore, it is crucial to consult the most recent edition of the NEC to ensure that electrical installations adhere to the latest safety standards. The brown, orange, and yellow color code for 277/480 volt systems is a specific example of a requirement that may have been updated or modified in subsequent editions of the NEC. Other areas of the code, such as grounding requirements, overcurrent protection, and wiring methods, are also subject to change. Consulting the latest edition of the NEC is particularly important when working on new electrical installations or making modifications to existing systems. Failure to comply with the current NEC requirements can result in safety hazards, property damage, and legal liabilities. Electrical inspectors typically enforce the NEC, and they may require corrections to any installations that do not meet the current code requirements. Moreover, insurance companies may deny coverage for losses resulting from electrical failures if the installations do not comply with the NEC. Therefore, staying up to date with the latest edition of the NEC is essential for electrical contractors, engineers, and anyone involved in electrical work. In addition to the NEC, there may be other applicable codes and standards that govern electrical installations in a particular jurisdiction. These may include state and local electrical codes, as well as industry standards such as those published by the Institute of Electrical and Electronics Engineers or the American National Standards Institute. It is important to be familiar with all applicable codes and standards to ensure that electrical installations are safe and compliant. The NEC provides a comprehensive set of requirements for electrical installations, but it is not a substitute for sound engineering judgment and professional expertise. Electrical work should be performed only by qualified individuals who have the knowledge, skills, and experience necessary to ensure that installations are safe and reliable. Furthermore, electrical systems should be regularly inspected and maintained to identify and address any potential problems before they lead to safety hazards or equipment failures. By following the NEC, adhering to other applicable codes and standards, and employing qualified professionals, it is possible to create electrical systems that are safe, reliable, and compliant with all relevant regulations. The specific color coding requirements for three-phase systems are essential for maintaining safety and preventing accidents in electrical installations. These color codes help electricians and other personnel quickly identify the different phase conductors, which is crucial for tasks such as troubleshooting, maintenance, and system modifications. The brown, orange, and yellow color code for 277/480 volt systems is widely recognized and used in industrial and commercial settings. However, it is important to note that other color codes may be used for different voltage levels or in different regions. For example, in some areas, a different color code may be used for 120/208 volt systems. Therefore, it is always essential to verify the applicable color codes for the specific electrical system being worked on. In addition to the phase conductors, the neutral and grounding conductors also have specific color codes. The neutral conductor is typically identified by a white or gray color, while the grounding conductor is typically identified by a green or beige color. These color codes help to ensure that the neutral and grounding conductors are properly connected, which is essential for electrical safety. Improperly connected neutral or grounding conductors can create hazardous conditions such as electrical shock or equipment damage. Therefore, it is crucial to follow the NEC color coding requirements for all conductors in an electrical system. The NEC provides detailed guidelines for the proper installation and identification of conductors, including the use of color coding, marking, and labeling. These guidelines are intended to promote consistency and clarity in electrical installations, reducing the likelihood of errors and ensuring safe operation. The NEC also addresses the use of different types of conductors, such as solid, stranded, and flexible conductors. Each type of conductor has its own advantages and disadvantages, and the NEC specifies the acceptable uses for each type. The selection of the appropriate type of conductor is an important consideration in electrical installations, as it can affect the safety, reliability, and cost of the system. The NEC also covers the requirements for conductor sizing, which is the process of determining the appropriate size of conductor for a particular application. Conductor sizing is based on factors such as the ampacity of the conductor, the voltage drop, and the ambient temperature. The NEC provides tables and formulas for calculating the appropriate conductor size for different applications. The NEC also addresses the requirements for conductor insulation, which is the material that surrounds the conductor and provides electrical insulation. Conductor insulation is typically made of plastic, rubber, or other insulating materials. The NEC specifies the acceptable types of insulation for different applications based on factors such as the voltage, temperature, and environmental conditions. The NEC also covers the requirements for conductor terminations, which are the points where conductors are connected to electrical equipment or other conductors. Conductor terminations must be properly made to ensure a reliable electrical connection and to prevent overheating or arcing. The NEC provides guidelines for making proper conductor terminations, including the use of appropriate connectors and tools. The NEC also addresses the requirements for conductor protection, which is the measures taken to protect conductors from physical damage, such as abrasion, impact, or exposure to chemicals. Conductor protection can be provided by using conduit, cable trays, or other protective enclosures. The NEC specifies the acceptable methods of conductor protection for different applications. The NEC also covers the requirements for conductor grounding, which is the process of connecting conductors to the earth to provide a path for fault currents. Conductor grounding is essential for electrical safety, as it helps to prevent electrical shock and equipment damage. The NEC provides detailed guidelines for conductor grounding, including the use of grounding electrodes, grounding conductors, and bonding jumpers. The NEC also addresses the requirements for conductor identification, which is the process of marking or labeling conductors to identify their purpose or function. Conductor identification is essential for troubleshooting, maintenance, and system modifications. The NEC provides guidelines for conductor identification, including the use of color coding, marking tape, and labels. The NEC also covers the requirements for conductor installation, which is the process of installing conductors in accordance with the NEC and other applicable codes and standards. Conductor installation must be performed by qualified individuals who have the knowledge, skills, and experience necessary to ensure that installations are safe and reliable. The NEC provides detailed guidelines for conductor installation, including the proper spacing, support, and protection of conductors. The NEC also addresses the requirements for conductor testing, which is the process of testing conductors to ensure that they are properly installed and functioning correctly. Conductor testing can be performed using various test instruments such as voltmeters, ammeters, and continuity testers. The NEC provides guidelines for conductor testing, including the types of tests to be performed and the acceptable test results. The NEC also covers the requirements for conductor maintenance, which is the process of maintaining conductors to ensure that they continue to function safely and reliably. Conductor maintenance can include inspecting conductors for damage, cleaning conductors, and tightening conductor connections. The NEC provides guidelines for conductor maintenance, including the frequency of maintenance and the procedures to be followed. In summary, the NEC provides a comprehensive set of requirements for conductors, covering all aspects of their selection, installation, protection, and maintenance. Adherence to the NEC is essential for ensuring the safety and reliability of electrical systems. It is important to consult the latest edition of the NEC and to seek the advice of qualified electrical professionals when working with conductors. The brown, orange, and yellow color code for 277/480 volt systems is a crucial aspect of electrical safety and should be strictly followed. Remember that color codes and other requirements may change over time, so it is always best to refer to the most up-to-date edition of the NEC.